So we're moving into chapter 7. And like I said, we're going to skip over the first bit of slides here about balancing equations. I've got a video in Black or in YouTube already that will go through those for you. I want to get us into the calculations though. And for the calculations, we need to talk about a couple of concepts that you're already familiar with. You're already familiar with the law of conservation of mass and its close cousin, the law of conservation of matter. Law of conservation of mass says that mass can't be created or destroyed in any kind of process. Long story short, the total mass of my reactants going into the reaction has to equal the total mass of products coming out of the reaction. In conservation of matter terms, every atom that goes in has to come out. And that's why we balance equations. Equation balancing is all about conserving the matter, making sure that every atom of hydrogen shows up in the reactants and in the products. There's nothing left over. Well, stoichiometry is a quantitative method that allows us to use this information about the law of conservation to apply it to calculations involving chemical reactions. And we come to stoichiometry by two means. One of those means you're familiar with already, mole conversion calculations, that is grams to moles, moles to grams, atoms to moles, and so on. We did a whole bunch of these calculations in chapter 2. We did a number of those calculations in our first dip into chapter 7 when we talked about empirical formulas. Now we're seeing them again. So that's one type of conversion that is used in stoichiometry. The other type are mole-to-mole conversions, and those use the balanced, those use the coefficients from the balanced equation. So balancing chemical equations allows us to satisfy our laws of conservation. We can then in turn use those to figure out the relationship between one substance and another in a chemical reaction and use that as an effective bridge to allow us to go between grams of one substance and grams of another substance in a chemical reaction. Now me, I'm a picture person. And this is the picture that I put in my head to help me try to organize myself with these kinds of calculations. This is what I call the mole map. You may hear it referred to as a mole diagram or a stoichiometry diagram, flow chart. There are a number of different names for this. What I like about this is this allows me to show how I can get from one substance to another substance simply by following the calculations between the circles. So let's say that I have 30 grams of aluminum, and I want to figure out how many atoms of copper I'm going to get in the end of the chemical reaction. Well, if I have a balanced chemical equation in tow, all I need to do to turn those grams of aluminum into atoms of copper is turn the grams into moles. We know how to do that. We did those calculations in chapter 2. Turn those moles of copper into moles of aluminum into moles of copper. Now with a balanced chemical equation, I can do that also. It's a 2-to-3 ratio. So I would set it up, moles of aluminum to moles of copper, putting in the coefficients as I went. And then I could go moles of copper rather, to atoms of copper using the conversion for Avogadro's number. Again, we covered that in chapter 2. So stoichiometry is really just an extension of the calculations that we were doing in chapter 2 regarding moles. All that we are doing is we're adding one additional step, and that additional step requires the use of the balanced chemical equation to help us to go between one substance and another substance. If I don't have the balanced chemical equation, I can't do the calculation. So we'll do more with this on Wednesday. I just want to kind of set the table because I know some of you have lab Monday and Tuesday, and you needed a little bit of a kickstart to help you do some of those calculations. Hopefully this at least helps a little bit with that. Have a great weekend.